Bam, bam, bam. Go. Oh no, really? Go. Oh no.
Fatality.
All right, so at the end of the episode one, Babi Papi Squad Custom Power Wheels was the first episode on this project. And where I leave off, I have my gearbox running. This was a 3-to-1 ratio gearbox. It spun really fast. It looked badass in videos and on the bench. But this ended up not making very much torque. It pretty much failed indoor testing. And I don't think I ever did outdoor testing on the 3-to-1 ratio gearbox. It would be great for something lightweight, maybe just a giant RC truck or something like that. But with two batteries and 32, 37 pound Babi Papi on it, and then resistance, uphill, downhill, I just had like barely any torque to move. But before I even get to the torque problem, this concept testing here, a lot of the work that had to be done was the throttle actuation. Which, if you see this piece that I'm holding, is the trigger switch from the original Harbor Freight impact wrench that all these parts came out of. So I had to build something to actuate that throttle switch that worked with the original button that's on the handlebars of the Babi Papi's quad. All right, so this is the piece that became my throttle management solution. What do I call it? Here, let's go to the CAD files. So I have this track bar piece. Um, it's gears along a straight bar. I have this little cutout here so that the end of the switch can go into that. This little piece that extends helps it keep stay in line. I played around with some different gearing because the servo was too weak to defeat the spring that's inside of that trigger switch. I printed this big washer piece basically to to help hold it from sliding out. I didn't want the track bar to come slip out from under the gear. I want it to stay in. I also have this ledge on this piece here that keeps it horizontally flat, and then that cap is holding it in, so it all stays together. So there's no binding or anything because this servo, this 9G servo, which this is a Metal Gear 9G servo, is fighting for its life to spin this gear to drive this track to defeat the power of the spring and actuate the damn throttle. Let's go ahead and play this. So first I made this cradle piece for this awkward switch because there's no mounting points, there's no hardware holes. It's irregular on the bottom because the wires soldered to it and they have fat beads of solder. So I needed like 6 millimeters to clear the wires. And then I finally made this little shoulder shelf so that it could sit in and it wouldn't move around. And then I backed it up on the end. And then this whole other piece that is the backing and mounts the servo and the gear idler mounts to it, basically bolts over the top of that trigger switch housing, and then the track bar slides across to actuate the switch itself. So this was like a day and a half of designing and testing. Then I finally programmed it with the button switch in the Pico. I spliced the wires and I'm going to ground. I made a ground switch basically with the original handlebar switch. And when I send the ground signal to the pin on the Raspberry Pi Pico, then it actuates the servo. And the servo actuates the original impact drill switch. So you can tell that servo is fighting for its life. But it worked. I'm really proud of this because this was like a whole little mechanical doodad just to make everything else work. Um, I came up with this on the fly, designed and tested it, and it did pretty good. Look at this part right here. This is my favorite part. I just love how badass it looks connected to the laptop. Having Babi Papi's quad connected to the laptop looks so freaking cool. It looks like you're doing some real ECU tuning. After making the throttle actuator work, doing some throttle actuator tuning, getting good throttle response, it looked super badass on the bench. But really quickly, indoor testing just down the hallway, this gear set, it the 3-to-1 gears, and it barely wanted to work. The motor would whine and it was just crawling to start off. If you gave it a little push, it kind of wanted to build momentum and go, but it just had nothing. It had no torque. And this is the original 3-to-1 using module 2.4 millimeter gears. Um, so I knew I needed more torque, and I started designing this set. I wanted to stay within the same cases that I have. I was avoiding doing a full case redesign because these pieces, they're complex geometry, I guess, but they're like 12 hours of printing. So I just didn't want to have to make new cases. I even settled for making modifications to this piece. This was the workhorse. I ran the original 3-to-1 ratio gears in this. So that's this set. And I ran the 8.7. I believe this came out to be an 8.7 to 1 ratio. Um, so I almost, did another multiple of three, almost three times, 3x the original ratio I had. And I made it fit in the same dimensions of the original gear case, um, by making this compound gear. I turned the idler into a compound, and I went down in module from 2.4 to module 1.4 so I could have more teeth per diameter of the gear. So now I have, I believe I did eight tooth off the drive, to, I don't know what this was. I think this was 44, and then I think this was 32 into 51, and that gave me about 8.7 and some change to 1. But the problem was because I double stacked gears and I only had 10 millimeters of width to work with, and that was due to like this right here. There's 20 millimeters of overall depth inside the case, but I have half of it is just these supports and this standoff. So there's only 10 millimeters left. And you'll think, oh, you got 5 millimeters of gear and 5 millimeters of gear, but I need to clear the bottom of the case. I need some standoff room for the bearing. I need to clear the other output gear overlapping the compound. So I had like 5.2 and 4.8 on one side, maybe. And I ended up just shredding the part of the drive where the idler would make contact because this was only about 4 millimeters of width. And so it was shred. I shredded like 3 of these drive gears, which it did make to outdoor testing. It would get along and move. It would boogie. It also wanted to do the thing where it wanted to like build momentum first, but it had enough power to spin the wheels, even if you held it down or a Baby Papi's weight on it or a super slippery surface. It would spin the wheels, and it had way more torque than this set. But I was just burning through drive gears. So basically, I knew that the problem was because this idler was so thin and this was stronger than the drive, even though this eventually, after burning through 3 drive gears, I also smoked this idler. The teeth are damaged quite a bit because, just pieces got cut up in there. Finally, smoked this piece too. But I knew the primary cause of failure was that these teeth were too thin. So I redesigned half the case, but it still works with the original first piece that holds the motor. So it's like a half redesign. I have some cutouts here so I can have bigger idler, intermediary gear, whatever you want to call it. I could still run every single set that I designed. I could run the 3-to-1. I could run the 8.7 modified with a thicker idler, more stronger, and I could run this new. I went all the way down to module 0.75. The 3D printer was able to do it, and it's been strong enough. This is what I'm running now. This has been the solution that it comes out to almost 24 and some change to 1 gear ratio now. And this is driving 91 tooth gear 0.75 module right to the metal drive shaft of the 88.7 motor. And then I use similar output. A modified version of this same output gear is also what goes on this side. They're interchangeable now that the redesigns have finalized.
Ray, go! Go! Turn. Come. Push your button. Go! Go! It goes quick! Whoa, there's a car. Wait for the car to go. Cool. Bye, car. Ray, go. You're waiting for the car.
Okay.
Whoa, stop. Good job, good job. Go this way. This way. He just want to leave. Well, it's climbing up this big hill. Out the driveway. It's pretty steep, actually. And he went over the speed bump.
Yo, so this is that's a good picture. So look, oh, we're in color now. Look at that. We're in color. Oh yeah. This is day 7 of editing this video. I don't know. It's like this is about to be a month. This is Thursday, August 6th. Friday's tomorrow, I assume, because today's Thursday. So hopefully this will be done and I can post this for the bot grinder viewers that care. Haha. um, it's taken so long. It's literally this is about to be 4 weeks. It's about to be a month since I posted the first episode. Oh man, I think I'm a little bit sick. Editing has been like pulling teeth. I don't know. I don't even know what I want to say or what's going on anymore. This is the freaking awesome 24:1 gear ratio setup. I forgot to switch out for the red filament, so this is all blue. Sorry, so the contrast is not awesome. But there it is. This was very experimental. I didn't have a lot of high hopes. I wasn't sure how this was going to work because I was going metal 20-volt directly to PLA plastic FDM 3D printer. So it was really just a test, but it worked out really great. I love seeing Babi Papi like excited riding this thing. He's always loved this little quad. This is the Hyper Toys like $40-50 Spider-Man quad from Walmart, by the way. That's where I got it. Pretty sure they still have it in stock if anybody cares or anybody wants to do this project. And these files will be on my Colts page eventually, but I'm just trying to cover as many things as I can. So it was kind of hard to film and chase Babi Papi around the parking lot at the same time and mention in the video while filming and chasing like all the milestones that were happening. But it was so freaking cool to see him enjoying it, just hooting and saying, "Oh yeah, like that was so cool." He's always loved this thing. He loves Spider Man, and we ride motorcycles, so he likes riding his little motorcycle. It's the best thing for us and him right now. But it used to move really slow. Like it was annoying. It had the power to move around outside. It even does not that bad in its stock form, like in grass. It does like okay, but it's kind of boring. He gets tired of driving it with the stock motor because he has to hold the button, and it just goes so slow. It goes slower than he can walk or run at this point with the stock motor. So like outside, it was just not that awesome for him. And then even for me trying to enjoy like going for a walk while he's riding it, it's like I'm stopping every 2 steps because it was crawling with the old motor with this setup here. And what is this? Original motor is a RS 390, 6 volt, 1600 RPM, and we stepped it up to that 88.7 running on 20 volts, and we're probably doing, I estimate, like 19,200 RPM is what I've been doing most of my calculations off of. Um, and so, yeah, I would say we went from like 5 miles an hour, maybe even slower, up to now. I'm estimating it should top out at 17 miles an hour. I don't know if we've ever gone that fast. I definitely have to like almost slow jog to catch up with him sometimes. But we're definitely doing, let's say, at least 15 miles an hour with this 24-to-1 gear ratio setup. Now, this gear, this first gear right here in this picture, I took a picture before I put it together and started running it. And that gear is this gear here. We finally shredded it or melted it. I don't know if you can see, there is a flat spot right there. It's pretty bad, pretty good, however you want to say. Um, but we got like 3 or 4 batteries out of that. And then I kind of felt like I was losing power though. I felt like it was going slower and slower. So I took it apart, and what I ended up doing was I kind of half-ass assembled the throttle management system. Like I had provisions for screws that I wasn't using because I kind of just wanted to slap it together and see if it worked, see if it lasted, see how long the gear would last. And so I felt like every battery was getting almost slower than the last. And it was because the servo was kind of starting to wiggle more, it was starting to bind more. So I took it apart, troubleshot it a little bit, and then threw some screws in it, and then it was able to really crank on the throttle switch. And I was getting a full 18 volts to the motor, and it was shredding. It was just you can actually tell the difference of the tire wear, like from the drive tire to the one that's just idling. And this tire is like all shredded up now. I'll probably do a tire rotation on Baby Papi's little plastic quad pretty soon because we're starting to get some tire wear on the drive wheel. But I don't know what else was I gonna say. After I cranked it up and I was getting the full 20 volts to the motor, we got around the parking lot pretty dang good. We got over around the bridge, under the tree, and then I think on the way back, after getting it really dialed in and full power to the motor, then we shredded. That's when we shredded the original gear. So I would say like on the fourth or fifth battery at full power, confirmed voltage to the motor, we shredded this gear. And then I printed another one, and not only did it shred even worse, and I think the reason why it shred worse was because I also blew the case. I snapped the bearing shaft. So I think that's why the second gear failure was way worse because it was all just moving around in there and got all tore up. Um, so the revised 8.7-to-1 and 24-to-1 is down at the moment. I have to revise the case. I'm thinking of maybe putting hardware through instead of relying on the FDM PLA case. But it was still a really fun project so far, really awesome. Um, I'm going to get back to it. I've definitely taken a break from it. I need to get back on it. The goal is to perfect it a little bit more, make it a little bit more reliable, and then offer all the STL files on my Colts page. I'm definitely trying to sell some downloads. That would help a lot. Um, I don't know. I got to get back into it. I got to brainstorm, see, figure out where I left off, make some improvements, and get back into it. But super great just to see Bay Poppy enjoying it and get some good results after all the work that I put into it. Um, I have a little bit of footage I'll show right now of Baby Poppy's official first power slide with the full power. That was pretty cool, and that's a moment. I'm gonna take that moment as the big win of this whole project so far. I gave Bay Poppy enough power to do a cool little power slide that's like a 2-second clip. So here it goes.
Oh, your Baby Puppy. Oh, yeah. High five, high five. High five. No high five, we'll find it. I gotta run to catch up. Running. Oh, Baby Puppy. Oh, wait. There you go. Yeah! Super speed, baby. Whoa! Oh, dirt. Go. Okay, make it. Oh, nice. Climbing skills. Ha! High five.
Flawless victory.